Alright everyone, welcome back to the day 22 of our daily leetcode challenge, and today we have got a classic problem called the map of highest peak. Now this is a graph based problem, and whenever they provide us with a graph based problem, there are two possible solutions. Either we use a BFS or a DFS. So BFS meaning breadth first search and DFS meaning depth first search. For this particular question we'll be going with the BFS approach, which is breadth first search, or also called as the level by level traversal. So what they mean by that level by level is that they will be providing us with a matrix of m cross n, which we can see here. So in that matrix m cross n, in the case of BFS, what we need to do is whatever initial values, there will be certain initial indexes, or you can say R and C values, particular places in the grids that we are gonna start with. So let's say in this grid we take this cell, and this cell to start with. These will be our initial values to start with. Now all these initial values will be going in the data structure called as a queue. Queue is nothing but a list in which you can add data from both sides and pop data from both sides, which is a doubly ended queue, and so we'll be using that. Okay, and once we have these values, starting values, we'll store their indexes in a list in this queue basically. So let's say this RNC, this RNC. So we're gonna have values in pairs stored in this queue initially. So these are tuples getting stored in a pair, in a queue. We are storing them in a queue, and we'll keep popping them from the left side. And once each cell is each row and column values popped, for each row and column value popped, we will have to look in all the four directions of it, which is the initial traversal for each. So that will be level 1. So each direction will have to traverse for each cell. Same as this as well. Each side will have to traverse. Same as this as well. So the order will be first this cell, then this cell, and then this cell. Since this is the order in which we have inserted them, and we have to. So this is the first traversal, first level of traversal. So there are a few things we have to keep in mind. After each traversal is done, we have to make sure that the cells that we visited, we have to maintain a set as well. And first of all the cells that we visited first, the starting cells that we visited first, will be going in that cell. That's step 1. And after that, once we start doing traversal in each direction, there are few things that we need to consider. First is we need to find a case wherein we have to don't look at places where we go out of bound. Like in this case, if you see here, we went out of bound in this direction, and in this direction we went out of bound. So we must not look in those directions, and we visited these two cells. Since these two cells got visited, so they automatically get added in this set. So this cell right here and this cell right here, both of these cells will get added in this set. Both these values will get added in this set right here. Why we are doing this? Because when this cell's traversal starts, we'll see that we went out of bound in this side, out of bound in this side, and when we go this side, we found that this cell is already visited. So we need not look again on this side. These two we are not gonna look, no way, because this is already going out of bound. But this cell, since it's already got visited, so we must not look. So this is a base case where we have to make sure that if the cell value is going out of bound, we have to not look, and if the cell is already visited, we have to not look. In that case, we only have to gonna look at cells which are not out of bound and also not visited. Only those cells will have to visit. And once we visit those cells, like for each of these R and C values, once we do that, we pop these values, go to all four directions, and then filter out the values which are out of bound or visited. In those cases, once we identify, like in this case, this was the cell which we visited. For this one, we visited this cell. Now since this cell is neither out of bound nor it is visited as of now, so what we're going to do is, if for the next iteration, once this is now in the level 2 of iteration, for this cell we're gonna start looking at the four directions. So before we do that, we'll have to again add this cell back to the visited, just like we did for the initials one. Just like we did for these cells in the visited, we'll have to again put these cells again back to the visited cell, and then do the same step which we did for the previous set of cells, which is iterating in all four and checking if we are going out of bound. We are going out of bound in this direction, and this cell will reach, this is already visited. Since we added this, already visited, don't care about this. This is not visited, so this will get iterated. So this is how a BFS basically works. This is how a BFS algorithm works. We start from each cell initially. Let's say we started with these cells marked at X, right? we started with these cells, this one and this one. So in our level 0 we are at currently level 0, which is starting with these 3 cells. For each of these 3 cells will start looking in the 4 directions. And how we will know which directions will go? We'll create another list which will have values like this: 0 1 1 0, 0 comma minus 1 and minus 1 comma 0. These are nothing but the coordinates in which we need to travel. This is going up, this is going down, this is going left, I mean, and this is going down, and this is going right, and this is going left, this is going up, this is going down, all 4 directions for each of these cells. And the moment we visit a cell, we have to make sure that we also maintain a set, so that a cell which is already visited is not again visited. So how do we, in this question, how are we gonna know which cells you're gonna start with? So now let's jump into the question that they have provided us. Let's see what they have provided us with. So right now what I just did, explained to you is how a BFS works, which is a level by level traversal. Now in this case we need to identify which cells we'll be starting with, right? So if you see, they have provided us with a matrix m cross n, which is named as is water. Now this is water is a binary matrix having values 0s and 1s. Wherever we have a 1, that would mean that there is a water there, and where there is a 0 is a land there. Now what they want us to do is, they want us to assign heights to the neighboring land cells. For each water cell, a height has to be assigned to the neighboring land cell, and for those cells again the process will continue. So for in the case, if you take a look at this one, this matrix that I have created here is actually the same thing that they have provided here, example 2. So this is a water cell right now, this is a water cell right here, these 2 are water cells. So for each water cell we have to assign height in a manner as in the neighboring one's height should always be 1 more than what they have right now. So neighboring ones get 1 more. So now since all these are visited, now for each of these cells again we will have to kind of do the same thing. Now imagine this as a water cell. Now what should be the height for this one? Now since this is what we are starting with, and we are going in this direction, this direction, this direction and this direction. Now again this is visited, so we don't need to care about this, so we won't be considering this side, but we'll go this side and this side. Each of these heights will be increased by 1, because the difference at most can be 1. We cannot have similar heights, so this at most 1 we need, so all these heights will be increased by 2. But if you see in the answer, they have only provided 1 here. The reason, because in the first iteration, in the first level of iteration, we'll be starting with these 2 cells, meaning we'll have this cell, and both of this cell will do iteration in the 4 directions. For this cell 4 directions, and for this cell also 4 directions. Now let's see which directions we won't be considering. We are going out of bound here, so we won't be considering here. These 2 are going out of bound, so we won't be considering here. These 2 cells is what we are iterating. These are not visited initially. Once we are here, so these 2 water cells are added in the visited set, their coordinates initially. This is level 0. We start with the iteration. We pop each cell, add the directions, those 4 directions we add to them, and then find which of them we don't want to pursue, because this is going out of bound. So this one we didn't take a look in this one. For this pair, the first pair, so these 3 are 1, because initially the height is 0 for a water cell. We'll have to kind of increase h. We can start with a variable h, which is 0 initially. For each of the first level, we are moving this side, so we have to make sure this h becomes h plus 1. So even though it's 1 here, the answer still will be 1, because 0 plus 1 is 1. So initial, in the 0th iteration, all of these are assigned as 1, the neighboring ones are assigned in 1. Now these 3 will be added in the visited cell. All these 3 will be added in the visited set. So we have 3 more pairs now added, so total 5. So this cell is done. Now we have to come with this cell. In this cell we are going in these 4 directions. These 2 are out of bound, we come here. In this cell also h value will be remaining 0 only, because we are iterating in this manner. So we popped this cell, the h value was 0. We set all those cells that we visited as h plus 1, which is 0 plus 1 1, and added those cells again in the visited set. So now the visited set has 5. This is our initial queue. This is our set, this big set. We are keep on maintaining values, keep on visited RNCs are getting added here. So for this cell, we added this already. The 3 that we visited gets added here. So this cell is done now. Now comes this cell. This cell is already added. we'll keep those visited set, in the 0th level we'll keep maintaining a queue, and we'll add them also in the visited set, so that when these are also considered in the upcoming iterations. So now for this cell which we pop, we'll go in the 4 direction. So these go out of bound, we don't have to care about them. And then comes these two. So step 1 is to set their height to h plus 1. So this will again be 1, and in the other step is to add them to the visited cell. So now these two also get visited. Now this is the iteration which we did. The 0th iteration is done now. So now in our queue, these two got popped. So whatever cells that we visited and set the height to h plus 1, we will now start iterating from them. So now in our queue, once these two are popped, we will be left with 1, 2, 3, 4, 5 new values. 5 new values for the second iteration, which will be the first iteration. This was the 0th iteration. These cells we popped. After popping each cell, these cells, this one contributed to 3 more, this one contributed to 2 more. So in the next iteration, our queue will look something like this. Our queue will look something like this. In the next iteration, our queue will have 5 values: 1, 2, 3, 4, and 5. These 3 getting contributed by the first cell, these 3 are getting contributed by the first cell, and these 2 are getting contributed by the second cell. Now again, these 2 are also getting maintained in the visited cell. We already added them, so that now so far in our visited cell, what cells we have? We have 0, these 2 as visited, since we already started with these, and these 3, 2 plus 5 cells also visited. So 5, since this is already included, so 5, and then this plus 1. So we total we have like 6 cells visited. Basically entire region visited as of now. So now we start with these cells that we have right here. Now the same thing is going to happen with them as well. For each cell pod, we'll go in the all four direction. So now we start with this cell. We are at this cell right now. These two go out of bound. This is already visited, and this is also already visited, so we don't care. Now comes this cell, the other one. We'll go in 4 direction. This is already visited, this is already visited, this is also visited initially, and then we'll come to this one, and we'll have to set this height to h plus 1 initially, and after each queue is emptied, we'll have to update the h to plus 1 for the next iteration. So in the next iteration, when we reach here, the h plus 1 will become, this 1 will turn to a 2, since we are replacing it with the h plus 1. So this is how a BFS algorithm basically works. We are doing a level by level traversal we are doing, and for each time we visit a cell, 3 things are going to happen. We have to make sure that we add that to the visited cell, change its height to h plus 1, and add that again back to the queue. Each of the cell visited has to be added back to the queue as well for the next iteration. So this might seem a little complicated, but when I'll code this up, you will understand. So to begin with, for what we first need to do is, this water cell right here, this matrix that they provided us, we need to flip this entire matrix, meaning what they have originally provided us, in place of land they have provided us with a 0 value, in places of water they have provided us with a 1 value. But we need to start with a 0 in case of water. As you can see here, we are starting with a 0 in case of water. So first operation is to basically simply just flip all these cells. In places of 1 we need a 0, in the original one they have provided a 1 where we have a water, but we need 0 in place of that we need a 0 in our final answer. So we basically, for our starting point, we'll flip this entire matrix, flip as in replace all the 1s with a 0 and 0s with a 1. So that will be first step. So we will be starting with something like this, which I drew in the first example, which is something like this. So what I mean by the flipping part is, we are having a matrix initially as is water matrix, which is a binary matrix indicating wherever there is a water, they are saying that it's a 1 in that in that row and column value. So initially they are provided us with something like this: 0 0 1, 1 0 0, and 0 0 0. So what this means is, all these cells are water cells wherever we have a 1. These are water cells, but in our answer you see that water cells begin with a 0, and from there on we build our matrix. So what we need to do first is, we need to flip this entire matrix. So after flipping, it will look something like this. We'll have to replace all the 1s with 0s and zeros with ones. So to do that, we can quickly redraw this, and now we are going to start with this. This will be our starting point. Now these are all water cells. Now for these two, we'll begin our BFS with these two R and C values initially in our queue. Our queue will have these two values, these two R and C's in the queue initially, and with each pop that we do, we'll move in 4 directions: 1, 2, 3, 4. And in those 4 directions, first we need to check if we ever went out of bound. We went out of bound in this case, we don't have to care about this cell. These 3 cells are getting the new ones which are getting. So again, since we started with these two, so we have to make sure that these two are also added in the visited set. That is step 1. So we are done with that. Once we popped it, we went to these 3 cells. We visited these 3 cells. So these 3 cells also need to be added in the visited set initially. So these 3 cells are added in the visited set. That's done. Now once we are here, we need to make sure that we update the height to h plus 1. Initially h will be 0. Initially h will be 0. All these heights get updated to h plus 1. That's second step. First step is to add them to visited. Second step is to make sure we update the height to h plus 1. And the third step, which is the most crucial step, is to add these values again in the queue for the next iteration. So initially we started with 2 values. After we pop this value, 3 values will be added in the queue. 3 values will be added in the queue, and in the next step, for this one, when this one gets popped, these 2 will be added in the queue, and their heights will also be updated to h plus 1. But before we do all that, we have to make sure that the check is also done. That is, we don't add values which are out of bound. We don't consider cells which are already visited. These 2 are the checks that we will have to perform. So now let's try to code this up and see how we can do this. So first, as I said, the first step is to make sure that we flip the cells. So again, for a matrix, whenever it's defined, it's always better to have the row and the column values like written by default. Like you can store it in this variable called len and call. This is a good practice so that when we are iterating this matrix, it's easier while writing the code. So now we have the row and column. Now what we need is a queue for our traversal, for our basically doing the BFS. So we'll take a DQ, which is a doubly ended queue, and what else we need? We also need the traversals that we are doing, directions in which 4 directions will be going, which is 0, 1, 1, 0, and 0, minus 1, minus 1, 0. These are nothing but the coordinates for this movement that we are doing right here. We are going in these 4 directions, right? For each cell that we are having, this is the cell right here, we are going in 4 directions. So since this is whatever this R and C is, whatever this R and C value is, we are basically going to a R, C plus 1, and then this is a R plus 1, C, and this is a R minus 1, C, or you can say this is R plus 1, this is a R minus 1, and this is a same row but column getting reduced, so R C minus 1. So if you see, what we are effectively doing is, we are basically for each cell 0, 1 operation is done for the R, C plus 1, 1, 0 operation is done for the R plus 1, C, a 0, minus 1 operation is done for a R C minus 1, and a minus 1, 0 operation is done for a R minus 1, C. So using these coordinates right here, we can traverse in all the 4 directions. 0, 1, 1, 0, this is basically nothing but a right move, this is a left move, this is a downward move. No, I'm sorry. See, this is our x and this is our y, right? So this is a y getting reduced. So this is basically up, down, left, right, bottom. So this is like up, down, left, and right. These 4 coordinates are helping us to move in those directions. So now since we have that, we also need to store these directions. So I'll store them in a list, and each of these coordinates are 0, 1, which is first, and then 1, 0. And then 0, minus 1 and minus 1, 0. So now we are able to cover all the 4 directions. This is done. Now we also need a visited set where we can store each cell that we visited, and we also need an h initially set to 0. So these are the things that we require to start with. Now let's start with the flipping part. We need to flip the matrix. Flip the matrix as in, wherever there is a 0, we have to put that to 1, wherever there is a 1, we have to put that to 0, and where there was a 0, we have to put that to 1. So basically converting this step that I showed you. Zeros get turned to 1 and 1 turned to 0, because in our final answer the water cells are 0 and in the question they have provided the water cell as 1, so we need to flip this. So this will be an easy operation. We just have to traverse the matrix. So if is water RC is equal to 0, this basically means that we have a water here, so this needs to be changed to a 0, else we'll have to change that to a 1, meaning it's a land. If it's water, put that to 0, and if it's 0 in the initial array, which meaning it's a land there, we have to put that to 1. Now the flipping part is done. Now we need to do the first, now we have to prepare our queue for the 0th iteration, meaning wherever we find a 0, we need to add that in our queue, that's step 1, and also add that to our visited set, that's step 2. We need to do these. So let's quickly do that also, prepare our queue for the first iteration. So for R in range of row, again we have to iterate this new matrix that we just modified. Now we need to check if there is water there, we have to add that to our queue. That's step 1, and other step is that to add that to the visited cell, because we just visited it, we don't want to visit these cells again, we are starting with these cells, so we added that as well in our visited set. Now the our queue is prepared for the iteration. Now we have to basically do this for loop on our queue. We're gonna return this, we're gonna keep doing this for loop and keep also adding the new cells that we are visiting, new cells that we just visited to our queue also, to prepare them for the next iteration. So this will keep on going until the queue gets emptied. So that's why we'll start with a while queue, meaning that we'll keep iterating this until the queue gets empty. Now we need to iterate the queue. Now we are at the 0th iteration. Initially our queue will have R comma C, these two R comma C's, this one and this one. So we need to pop these. At the 0th iteration we pop them. Now since we pop them, as we said, since for each cell we pop, we have to go in the 4 directions. 4 directions we need to go. So how we can do that? All those 4 directions we can get from this direction row list that we created. So this can be, again we have to do a for loop on this direct list. Since this is of just length 4, always constant, so this won't affect the time complexity much. So for dr comma dc, these are the directions that we are traversing in. We'll get a new row and column because we are updating these values, right? We got these. Now again I told you, once we have this, once we are moving in those 4 directions, as in this, these are the 4 directions we are moving in. For each R and C, we added those values 0, 1, 1, 0, 0, -1, -1, 0. We're going to reach at these 4 values. For each of these values, you need to check if we are going out of bound, that is check 1, and if we already visited that set. If we are going out of bound, or if we already visited, in that case we need not pursue those R and C's. So that check right now we're going to do. If we are going out of bound, this is the case if it's going out of bound. So this that you see right here is the case where we are checking if it's going out of bound, greater than equal to row, greater than equal to column value, less than 0, less than 0. This would, if the values are, any of these are getting satisfied, it means that R and C value is going out of bound, going out of this entire grid. We don't want that. So that's one. And the second thing is, this R comma C should not be in the visited, because if it's there in visited cell, then also we need not check them. So once this happens, we can simply kind of terminate that loop and switch to continue for the next iteration. So for this particular R and C that we moved, in whichever direction we moved, if any of these cases are getting followed, meaning it's going out of bound, or if it's already in the visited set, then in that case we should not pursue it. And if that's not the case, we do visit a new cell, like in this case, this was an out of bound condition, right? This was an out of bound condition, this was not good, but these 3 cells are not visited yet and they are new cells. So what are the things that we discussed are going to happen? First is, we need to add them to the visited, that's step 1, add them to the visited set because we just visited them. The second step is to set their height to h plus 1, and the third thing because this initially is 0, we need neighboring cells to be at least 1 plus to the one that we are at currently. So all these heights, so first step is to add them to the visited set, because we just visited, add them to the visited set. We are talking about these 3 freshly visited cells. These are neither going out of bound nor they are visited currently at the particular iteration. So what is step 1? Step 1 is to set their height to a h plus 1, because h initially at this case is 0. We set them to h plus 1, that's step 1. The second step is to add them to the visited set, because we just visited them. And the third step is to prepare these in our for the next iteration. So to do that, we have to add all these 3 new visited values to the queue as well. So these 3 steps we need to perform. So first is that we'll have to add them to the visited set dot add new r comma new c. This gets added, that's step 1. And the second step is that to change their height to h plus 1. That's second step. And the third step is to prepare them for the next iteration. So we'll have to again add that in the queue that we created. So these 3 steps we performed: added them to the visited set, added their height to h plus 1, set their height to h plus 1, and prepared them for the next iteration. So this just happened. Now this will keep on happening for each of these cells that we are popping, each of the cells we are popping. So once these are done and h is set to h plus 1 for the next iteration, this is where the iteration ends for a queue at once. This is our 0th iteration getting ended, which we just did. 0th iteration got ended. H was 0 initially. We set their heights to h plus 1. In the next iteration, the same thing is going to happen, but then for that h plus 1, this has our h has to be updated. So now we'll be operating with the h is initially 0. We set them to h plus 1, 0 to plus 1. But now for the next iteration, we have to make sure that the h is updated, because we'll be going plus 1 for the next cells. For the next cells, we'll be doing a plus 1 in the h. So we have to update the h value, and this that update is going to happen at this line, h plus 1, because our iteration is a particular iteration gets ended at this loop right here. This is where an iteration ends. So this is exactly where we'll have to update the value of height as well. So now once this is done, we'll basically let this happen, and the queue will finally come to an end, which will get empty. And once we have that, we'll just have to return this is water matrix that we just had. So if we run this now, we are getting a visit. All right, visited seems to be a spelling mistake. All right. I think I've renamed it a couple of times as a visited. See, spelling mistakes are the worst of the worst. Can't believe this. Alright, I think that's the last of it. Yeah. Now if you submit this, you'll see that it's going to satisfy all the test cases. Alright, so if you see, this is this solution is getting accepted. So this is how a BFS algorithm works. We are doing a level by level traversal. We are starting initially with these two cells, and for each cell we are doing all 4 directions we are traversing. And there are few things that we need to keep in mind, which is basically kind of a base case to terminate a loop. What those cases are: if it goes out of bound, we need to terminate the loop. If the cell is already visited, in the first case, all these new freshly visited cells, so we did consider them. But for these cells again, if you see for these 3 cells, when we will be doing those 4 direction operations, you'll see that all of them will be visiting this cell. All of them will be visiting this cell that they started with. Since this is already visited, so they must terminate this loop. That is why that continues there in the end. Terminate that loop. And for each of these cells now, when they are visiting to the new cells, their height was initially set to 1. Now they will be getting set to h plus 1. So that is why this is how the loop is working. This is how the loop is actually doing that h plus 1 operation, right? And this is the solution right here. And if you have any queries, you can ask in the comments. And this was it for today. Like and subscribe, and I'll see you in the next one. Bye.